Hey guys, so I got the new nuts from the guy on eBay. I'll I'll tell you who that is later. I don't remember off the top of my head. Uh, he's on eBay. Mike Nelville. He's in Kansas. So uh, let's unbox this and see what these things look like. Okay, so let's see what we got right here. This is just packing material. So there's two nuts, seem to be packed pretty good. Alright, so this is, to me, looks like it's going to be a cross slide. I'm sorry, the compound seems big for the compound, but we're going to compare it to the old one. And this guy right here is, so that's kind of interesting. So this one is for the cross slide. If you remember before, I was talking about this right here is threaded. This is the socket cap screw that holds the nut in, and this is where the pin goes. And if you notice, I don't know if you can see here, this hole is not drilled all the way through. On my lathe, this hole is all the way through. So when you tighten down that pin too far, it actually goes through into the threads and binds on the lead screw and doesn't do what it's supposed to do, which apparently is you loosen this guy up a little bit and you tip this down, and that takes up some of the backlash. Seems like an odd way to do it. I think I remember working on my Bridgeport, and it has a split nut, and you can I believe there's some kind of a screw in the middle of the table, and you thread that down and it splits the nut. All right, so let's go grab the old nut and the lead screw. Let's see what the difference is and how it shapes up. Okay, here's the original one right there. So let's see if you can see the difference between the two. So they look about the same. This one obviously is quite a bit longer. We'll see if that fits. That's about the same. That's about the same. This is cast and then machined. I did try a suggestion that a guy put in the comments, putting this in a press and squashing it down. I maxed out my 20-ton press and it didn't do anything. So maybe I needed more pressure, I don't know. Anyway, let's thread this thing on and see how it seems. Well, it's definitely okay, so I don't know if you can hear that or see it. There's no slop. So from that standpoint, it seems pretty decent. We'll just do a comparison, so I'll show you what the other one does. You can almost hear it rattling in there. That's quite a bit of slop. And if you notice, I'm at the end of the lead screw. But I think I mentioned before that the amount of slop was the same, whether I was here, or in the middle. It tells me that the screw is actually in good shape. So I'm going to put this other one on again, and let's just double check the side to side. You can tell as soon as you start threading it in, it just is much tighter fit, and you would expect that. Very, very little. You can't obviously there's some, you have to have some clearance, but it's very tight. All right, so let's see where this thing mounts in the compound, and let's make sure that this extra length will in fact fit. All right, so this is the base plate for the compound. Here's your angle positions, and so this guy fits in here. So I don't see why it wouldn't fit. We'll just double check to make sure that we still get the full travel. That seems pretty good. So the other thing that we'll figure out is to make sure that obviously this is a crude way of measuring right here, but they seem exactly the same. But maybe I'll put it on the surface plate and just see where we are relative to that. Then I guess as far as the other dimension we would want to check is the center line of this bore to the top of here to make sure that, you know, we're in the right position up and down. So I think first pass, they look pretty good. This one, obviously, I'll have to take the cross slide apart to get this one in, and we'll have the next video, we'll go through that process. So anyway, I just thought I'd give you a little peek at my new parts. Again, it came from a fellow right here, Mike, looks like Neville. Lead screw, repair, crossfeed nuts, PayPal accepted, free shipping. There's his number and his email. Again, I found him on eBay. So these parts were around $200 for both. $198 included free shipping. There was a fellow that commented that, you know, for that price I could have bought the tools to do this, and he's absolutely right. The issue is time. I right now I'm pressed for time. I just needed these parts, so I had to do a cost-benefit analysis on my time versus just getting the nuts, getting this machine put back together, start making things, and that's why I made the decision that I did. So yeah, it would have been a fun project. I would have preferred to have made them myself and you know, bought the tools, which would have been this Acme tap and then this Acme tap, which is I believe this is left-handed. So I don't imagine those taps would have been cheap. I mean, I guess I could have cut an Acme tool, threading tool, and just did a single point threading. I'm not sure how this guy did his. Anyway, I chose to go down the path that I went down. So I'll bring you back when we're ready to get these things fit into the lathe. All right, guys, just real quick back at this. So this is the hold down screw for the nut on the cross or the compound. So you see that threads in, no problem. This guy might have some junk in here. I can't. It doesn't. It's gritty. Maybe a little bit of junk in there. So took my trusty Starrett tap holder and a what do we have here? A quarter 20, and we're just going to go in here and clean these threads up. I'm not using a bottoming tap because this is tapped way longer than the thread length on the hold down screw. So let's see if we pull any stuff out of there. A little bit, not much. So let's see what happens. Perfect. Okay, think there was just a little bit of junk in there. All right, just wanted to point that out. All right, guys, so just, to do a little test fit. So I put the new nut in, just kind of threw the retainer fastener in. But what I wanted to check was, what is the impact of this different length, and should I machine that off to this length? So I installed it onto the top part of the compound, right, like this. Okay, so now it's not really a problem in this direction, and I'll show you why when you come back here. So this piece bolts on right here. Let me get you in a better spot here. So you can see this piece bolts on right here. So because of the way the dovetails are set up, you can't come back any further than that anyway, right? Is that what I'm thinking? Right, so if you're bolted on right here, that's the limit of travel, because, sorry again guys, because these guys are going to hit. So in the other direction, however, so this is all the way back, and if you notice, right here, this is all the way back. So I'm assuming that we're stopped up against the nut, and here's the compound hold down bolt, and you see we're right to the front edge of that. So I checked my other lathe. Let me just show you on the other lathe. Sorry for my fingers. So if you look on my other lathe here, so if I were to, I'm pulling this guy all the way back. So this is showing me how much travel we have. Okay, so the leading edge is basically the center line of this. So this is all the way back. And if I thread it all the way in, you'll see that it's going to stop. Right there. So I don't think we have a problem with this guy going this direction. Right, we're going to stop right there, just like my other lathe. So what we've lost is approximately, I don't know, half the diameter of that hole, whatever that is. I believe it's probably a 3/8 clearance hole, so half of that. You know what? I think if you're working that far to the end of your limit, it's probably not advisable anyway. I'm probably going to go ahead and just leave it that way and not machine the end of the new nut off, because the more area we have, I would think the longer the new nut will last. So I'm going to leave it the way that we have it. All right, I'll bring you back when we get this thing assembled. All right, guys, I got it all back together. So I got my compound back on with the new nut in it. I have the cross slide on with the new nut. We've got the backlash way down, so pretty happy with that. I'll show you what that looks like. But so a little, let's say, an honesty moment. So what I found was, when I was disassembling this to change the nut, that this clamp bolt right here, which clamps this slide assembly, which locks the taper attachment, that was not tight. And so when I tightened it up, about half of my backlash in the cross slide went away. So this guy was rocking back and forth a bit, and that was giving me some backlash that I could measure when I would grab a hold of the compound and slide it front to back. So again, if you guys have a taper attachment out there and you have excessive backlash, I would look to see that your taper attachment is properly set up. With all that being said, I still had quite a bit of slop in that screw, so I'm reasonably comfortable with the fact that I changed it out. This definitely, on the compound, was definitely worn significantly, so that there's, well, let me just show you right here. I'm gonna say, I'm just running it up against when I feel it hitting something firm. So looks like about 5 thou. I don't think that that's awful. So pretty comfortable with that. And you know, I probably could tighten that up a bit more by canting the screw or something. But you have to have some backlash. So I think that that's appropriate. So what I'm going to do at this point is I'm going to start working on making that replacement retainer for the wiper for the quill. So let's get on that. All right, guys, so there's a hunk of 303, I believe it is, stainless. I'm going to put it into the cutter saw. I'll just measure probably, I don't know, 1/4, 3/8 of an inch, something like that. And I'll chop that off, and then I'll have my piece ready to get in the lathe. So let's get this thing set up. All right. I did it dry. I just put a new blade on, a finer blade, so I'm pretty happy with how it came out. So let's go get this thing mounted up in the lathe, and we'll get it faced off and start that little machining job on the recently completed 10EE that you guys have watched the restoration on. So let's get to it. All right, guys, well, hopefully the noise of this machine isn't too overwhelming. So let's get this mounted in. So I'm going to change this chuck later, but I will just get this cleaned up for now. Okay, let's see what it looks like. I'm going to tap it in with a dead blow. It doesn't look like it's flat against the back, but this is just soft cut. Let's see if that helped. That looks pretty good. All right. Want to check for some clearance here, make sure I'm not going to crash into anything. I've got plenty of room here. All right, so let's face this off. It's probably not the right way to do it, but this is the way I'm going to do it. Probably, I'd have to go find another chuck that I have that I could spin these guys around. I don't think I have the other set of jaws for this particular chuck, so let's do it this way. About 700 RPM. Hey guys, this is it, man. First checks, right? Alright. So what I'm going to do is I'm going to get the feeds engaged so that we can use the feeds. Belt feed, open belt, feeds. Okay. I got it at a very slow rate, so let's see what happens here. That's too slow. Let me speed that up. You know, it's funny. It feels like I'm definitely a newbie at this. All right, let's stick it right there, and I'm going to go with. Let's see if that's better. More like it. Alright, so that looks like a pretty nice finish actually. I'm going to spin it around and I'll clean up the other side. This way, in case I have to flip it around during this machining of this thing, I can, I've always got a nice true surface. Relatively true surface. Doing this assuming that the faces of that jaw are flat. I don't know that they are. I'm going to see where we're at, and if I think we need to pull it off and then tap it in, I'll do it. So let's see what we've got. It looks pretty good. So, the chip breaking is awful on this because I'm not really using this tool the right way. I'm trying to just stay away from here. I think I'm going to change the chuck out. Anyways, I guess from the standpoint of machine operation, the chip cutting, how solid it is, noise, I'm pretty happy with it. So let me see about changing this chuck. Alright guys, I put this 6-jaw on here. So very fortunately, one of my other lathes came with this 6-jaw. I think it was the one that I had redone a couple years ago. So it's a buck 6-jaw true set, or whatever the terminology is, so that you can actually tweak this thing in. The reason why I think 6-jaw is the way to go is because on my little disc right here, I got to hog out the center, and with just 3, or even if I put in a 4-jaw, not a lot of surface area. So I think what I'm going to do is use this guy, and then we'll equally distribute the force. So what I'll do is put it in and then tap it around to get this face running true. I think my plan will be to reduce the thickness on there. I cut it too thick and I just don't feel like cutting another one, so I'll shave a bunch off and get it much closer, so I'll have some stick out going here. But with 3 jaws, I'm pretty confident that we'll get a good bite on it. I guess the other thing to think about here is it's going to get pretty flimsy as I get it thinned out, so I guess I have to think about that a little bit. Anyway, I'll bring you back when I get this thing chewed up and we start making some. So guys, I've been whittling this thing down to get it closer to thickness. I have about 100 thousandths left to go. So if you remember, this is the part that I want to make. So what I did is I want to round this edge off, and before I get any closer, I think what I'm going to do is round it off. I round up a little tool. I'll give the edge that I want, then I'll flip it over and then face the back off, because if I take 100 thousandths off, I think I'm going to be a little too close, I think. I don't want to risk it, so, well, let's see what we got. Alright, so, we want the thickness to be 202, and we are at, I got 84 thousandths left to go. So, maybe I'll just keep going at it, because if I take 80 thousandths off, let's see here, I'll zero this thing out. Let's see, about 80 thousandths. Yeah, I'm gonna have to flip it over. Okay. So we'll get this tool out, and then we'll get that going. All right, guys, I'm gonna come in here and give that a little touch. It's pretty close to the chuck, so it's gonna be really careful. Alright, I'm pretty happy with that. Again, it's really just cosmetic. I don't have to be too concerned about it. I just didn't want a sharp edge. Alright, so now what we'll do is we'll flip this thing around and I'll clean up the backside. Alright, so we're going to have to pump it in. I'm going to take very, very light cuts because I'm just really on the edge of this thing. All right, let's see. I'm going to put my indicator over. Okay, it's about 1,000, so I'm going to be good with that. Make sure I'm smart with that. Okay. Alright, so I'm going to set my caliper to the target dimension, which is 0.2. Alright, and I'm at, I'm going to zero it, and I'm at 86, so I have to take 86 off. Okay, so what I'll do is, I'm going to try this tool. I didn't try that one before, we'll give this one a try. So we're going to take 82 off. Alright, so let's see here. try a little bit of lube on it. Alright, I hit it with some lube. Chip breaking is really poor. What I didn't realize here is that the insert had actually chipped, and so that was why I was getting bad chip breaking and that sort of edge that was building up. You can see. The other thing is you'll notice when I back out, it's dragging on the work earlier in the video, and that was because I wasn't locking down the carriage. So I think it was probably pulling the carriage in as it was cutting and then dragging on the way out. And you'll hear that in a minute when I come back. Right there, you can hear it. I don't know if I should try a little more speed. I'm at about, I'm going to go to 800 right there. I'm really taking very light cuts because I just don't want this part to fly out. Okay, we're there. Alright, so the next thing I'm going to do is I'm going to machine that out. Again, this is not, aerospace accuracy stuff, but I want it to be relatively close. I'll bring you back when I'm getting ready to do that cut.